Hello Ocean Avenue students. My name is David and I'm a water treatment engineer, which means that I go into certain sites and I test water and I inspect water treatment equipment. That's basically what I do. I'm a petrochemical engineer, but you don't have to be to do what I do. You can have any kind of background knowledge, but you do have to know what you're doing and be able to take and pass the licensing exam in order to be a water treatment engineer and do it at secure sites. So anyway, basically when I come into certain sites to test the water and to check the equipment, I'm making sure that I have my PPE. So I have my vest, I have my steel-toed boots, I have gloves, I have safety glasses, I carry my license in case anybody wants to see what I'm doing. Also, I wear a uniform, and this way when I come on site, security and the people who work there know what I'm there for. So they don't have to question me and I don't have to waste my time explaining what I'm there for. Because I want to just come in, check my systems, and do my job. So basically I'm bringing in my gloves. So I have climbing gloves, I have rubber gloves to do my testing. I always bring a wrench in case I have to open a valve that's maybe stuck. So I always have that on me. I always carry a multi-tool that has different kinds of screwdrivers and different types of blades and things that I might need to do my testing. So anyway, I'm going to jump right in. I'm going to do some water testing right now for you guys. So I don't need those gloves. I'm going to put on my latex gloves or polypropylene gloves, and I'm going to make it safe. So right now I have a water sample right here. I'm going to bring in my bucket. I'm going to put on my glasses. Even though the reagents that I'm using are quite safe, I want to make sure that that nothing splashes in my eyes. If it does, I'm going to go to the eye wash and I'm going to wash out my eyes. Okay, so here I have my water sample. I'm going to start out with my multimeter. This tests different things like conductivity, total dissolved solids, pH. So I'm going to start right out. I'm going to rinse my multimeter at least 4 times. I like to go an extra just to make sure. And there we go. So I push the button, and this is for my conductivity, and it is 312 microsiemens at 63.1 degrees Fahrenheit, because that's will change with temperature. Then I'm going to hit the TDS button, which is going to give us total dissolved solids, and that is going to give me 211 ppm solids, dissolved solids, also at 63.1 Fahrenheit. I'm going to hit the pH button, and it's coming right in at just about 7.9 pH. Now I'm going to do some titrations to test for certain things in the water quality. So first I'll test for hardness. So I'll start out, let me move this. I'm going to use my little vial. I'm going to go to 25 milliliters. I am going to add a hardness buffer. Then I'm going to add 2 scoops of hardness indicator. Didn't get quite a full scoop, so I'm going to make sure I have that. And as you'll see, it comes up and it's a pink color. So basically I'm going to titrate with my hardness titrant until it turns blue. And I count the drops. 1 drop, 2 drops, 3 drops, and 4 drops. And that gets us a nice blue color. Each drop is 10 ppm. So 4 times 10 is 40 ppm hardness. Okay, now I'm going to move on to alkalinity. I'll rinse my vial. And I'm going to add phenolphthalein indicator. Now typically if the pH is over about 8, and we're close, it's going to give us a little pinkish color. So I'll do a titration to get rid of the pink, and it should just take 1 drop so I get the clear. Now I add a methyl green, which is a dye, but it's pH sensitive. Add 5 or 6 drops of that, and then I'm going to titrate again. So that would be 2 drops, 3 drops, and I'm going to go a little bit more. And so I'm going to call that 35, 3.5 drops. So 35 ppm alkalinity. Now I'm going to test for chlorides. I'll add the phenolphthalein indicator first. Just a few drops of that. Then I'm going to add my potassium chromate, which is a indicator for chlorides. And then I'm going to add my chloride titrant. I'm going to do this dropwise. And let's see how many drops. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm going to call that just about 9. So each drop is 10 ppm, so that'll give us 90 ppm on the chlorides. So we got our water sample, and that's what we have on our number. Now, why am I doing this? It's to see what the water quality is in the water, and just to see how the water is going to react in an industrial or commercial type situation. One thing that we do when we're especially doing cooling or boiler, we have a controller, and it would be something like this. And this controller, we put a set point on there using a probe that's in the water stream, and the probe would cause the controller to open and close a valve to drain out some of the higher conductivity or higher TDS water, and then you'd make up with makeup water. I also have a flow switch here, so that's something that we install in line to make sure that we're not bleeding when the pump isn't running. I also have a iron test kit. So if I do see some orange to the water, I'm worried about iron levels, I'm going to test the iron levels. And I'm going to see what it is, and that way I can track it. Maybe I want to bleed down, maybe I want to do some adjustments to the chemistry to get rid of some of that iron. So anyway, what does that really mean? So I've got my conductivity scale here, and here's our set point. And if you go higher than the set point in conductivity or total dissolved solids, it's going to foul. If you go much lower, it's going to be corrosive. You're going to be in a corrosive situation, and you want to avoid that. And basically the water conductivity is proportional to total dissolved solids. So that's the minerals that would be dissolved in the water. And basically, if you have too many minerals dissolved in the water, you hit a saturated point, and then you can hit a supersaturated point where the minerals start to drop out. And that can plug up your pump strainers, that can collect in your heat exchange tubes, and that's not good for the system, because basically the whole system can shut down if you foul it. Now let me talk a little bit about pH range. pH range is basically from 0 to 14. 7 is neutral, and that's what pure water would be. So if you're around 0, then you're in the acidic range. If you're towards the 14 or above 7, you're in the basic or alkaline range. And basically you can adjust the quality of the water by using acids and bases. So I put down a simple formula here where I'm neutralizing hydrochloric acid with sodium hydroxide, also known as caustic. And what does that make? Sodium chloride salt, which is table salt, you know, what you put on your food, and then a byproduct, which in this case would be water. In every case, if you have an acid and base reaction, if you mix an acid with a base, you're going to get a salt plus a byproduct. So that's basically the quick primer on what I'm doing, and I'm open for any questions. So Ocean Avenue, feel free to reach out. This is a business that I love to do. I make my own schedule. I go to my sites, I do my testing, I do my reports, and I get them out to the customer, and then they can make adjustments, operational adjustments, based on what I'm doing and what I'm seeing. And in some states, like in New York State, this testing and inspections are required by law, and it has to be done. They also require Legionella sampling to make sure that people aren't getting Legionnaire's disease if they end up breathing in the water vapor. So these are all things that we want to optimize, avoid any kind of bacteria growth. Oh, by bacteria, I almost forgot, I do test for bacteria when I go in. I use a dip slide. And basically when I do that, I'm taking my sample, my dip slide, and I pour the water into the vessel, and then it's just like it says, it's a dip. I dip my dip slide in, and I make sure that I get good contact with the agar. Dump out the water, and then there it is. I incubate for 48 hours, and then I count the bacteria that's on the agar, and that's telling us how much bacteria is in the water. So this way I can tell whether it's safe to be around or not safe to be around. And that's why I do wear the gloves, because I don't know what the bacteria is until the results come in. So I want to make sure that it's safe. Anyway, that's it, Ocean Avenue. Have a great day, and let me know if you have any questions. Thank you.